Okay, I guess it's close enough to 7 o'clock. 10 seconds, oh well. So, today, or tonight, we're going to revisit what I was doing in the last video, so last night. And I'm just going to revert back to a previous save, and we're just going to rebuild basically the cutout part. It saved pretty close to where we're at, but this needs to be turned around. It was wrong in the z-axis. So this is what I designed for, which has this little notch in the corner down here. But the part I had was actually for the side over here. So this part is what should be over there. So to correct it, negative, it should look like that. Obviously, because I Booleaned it, I gotta start over, and well, that's what you get for using Booleans. And this is kind of a mess. So we're gonna go ahead and open up the correct one. The 3D printer is probably gonna start up soon, so if you hear a weird sound, that's what the printer is making that sound. So I'm gonna revert back to the previous one. I'm not gonna save that. In the previous one, we have the part here, and then our, I think this is the pre-adjusted shape. So it's just, I just rotated the position, and that's all I did. But, I know what I'm doing, so it shouldn't take that long. So we'll fix the part first so we don't make a mistake again. So this is what the part should look like. Resistor up front, chip on the back, and the cap right there. The wires are going to be connected there. Let me just grab the parts really quick. So, give anyone who's watching an idea of what is actually supposed to be going on. Let me grab my camera. More cable. Seem to be out of wire. Close enough. So I will cut to the camera. So this is the part we're talking about. This is the side that we're going to be printing. So the resistors over here. Sorry about that. So the resistors are over here, and on the back there's a so I'll get a better camera hopefully the next time I stream. Caps on this side. So I should have been designing this one, but instead I was designing the one on the end, which has the resistor on the front, which causes me to start over. So on this one, the wires come out the back here, and I'd like them to go underneath so that I can hide them. Basically, some good wire management. But I don't want the wires on the front. So the only thing on the front you'll just see is this. That allows me to put the little shield in front, or the gels that have the colors for red, yellow, and green on the front here. So let's get started. Cut back to the computer. Put my mic right there. So, this is kind of where we left off. I closed it again. I'm just going to fix this really quick. Get this positioned. This should be our top view. So your orthographic top. And let's remodel this really quick. I see I actually have one person watching me right now. Thank you. If you like what you see, please subscribe. So this is, for anyone who missed the first live stream, I am building a fully 3D printable Guy-Manuel Daft Punk helmet. I'm going to undo these because I did it again, where I am modeling world. There we go. This is a 3D printable Daft Punk helmet that you can print on any size 3D printer, and that is the sound of the printer you may hear. Starting up, it is printing my fan blades for the. Just cut to the camera real quick. So these are the fans that will go in show all. So this is the fans that go along the edge, and these will hold the LEDs that are rainbow colors. I think it's purple at the top, and then it's green at the bottom, and it just kind of makes a rainbow color. And they blink back and forth. So if you don't know what a Daft Punk helmet looks like, just look up Daft Punk helmet, and you'll see a pretty good example. The best example I've seen so far is Boolean Props made a fun video. It's on YouTube. You can watch it. I'll add it to the description in the YouTube video after it's been posted. But we're not going to work on this right now, so I'm going to rehide everything. And what we're working on is the electronic mount. And I'm fixing what I messed up yesterday, because I designed for the left side and not the right side. And there's just some annoying notifications from work. Some things I deleted today are now just syncing to my computer. So I'm just fixing or rebuilding this part of the helmet. This is a bracket mount for the EQ meters and I guess the chin lights for this particular helmet. So if you have any questions, feel free to put it in the comments or in the chat in the live stream. I am watching it. What I would love to have out of these live stream series is people suggest ideas for me to build. Tips and tricks with Maya, basically anything. I want to be kind of not the go-to guy, but at least someone that has the experience with all these products and uses them on a regular basis, but not necessarily for their intended purposes, and what's the best way to do that stuff. If you're new to 3D printing, I'm fairly new. I'd say I've been using it for a year, and I've got my printer pretty dialed in. It prints stuff just by hitting print. It's like a normal printer, at least a printer that's actually working, not the printer from Office Space, because that one's not a normal printer, that one's from hell. So I think that's pretty good. We'll check it out in the 3D view. Object. So looks like I need to lower it down a little bit. Got a little out of position. So it lines up. The trick is with this piece has to be perfectly flat, even when I rotate it back to being 17 degrees. So that it can print easily on my printer. So this should be 6x6. You can double check it just by throwing in a plane and saying 150 millimeters by 150 millimeters. So we'll just do that. And this is the print bed. And what do you know? It'll print on my print bed. And you just glue two pieces together and you have the mounting brackets for the electronics. So now that we have it partially fitted, there's a little bit more readjustment. Let's see here. I think I'm still in world mode for editing. That might be why this is being difficult. Yeah, so I plan on only doing this for an hour because I actually have to start sanding the visor mold for this. I'm bringing it to a vacuum former in Minneapolis to actually get it made. If you follow me on Twitter or Facebook, you'll notice that I posted photos of a sheet of plastic that was bent horribly. I tried to use a heat gun to get my desired result for a visor, and it failed miserably because I can't get it hot enough. So I'm going to spend the money and get it vacuum formed. Hopefully it's not too much, probably $80 or less. My mouse is tweaking out. Okay, so now we can extrude this. I think the last time we extruded it, it was 4 millimeters thick. Basically, it's going underneath this lip, so I'll be able to just glue it from the underside. It doesn't need to look pretty. It's just a structural piece to hold the electronic boards. and enough of the board is actually through the plastic. I might raise this up a little bit, just so there's something for it to sit on in the final piece. So to extrude it, I will just hit extrude, move into my attribute editor, move it down a little bit, because I always forget which number it is, and it's always that one. And I'll say -4 millimeters, so it's going to be 4 millimeters thick, so roughly half a centimeter, which is a decent amount of plastic. I just want it to be strong because this chin piece is already kind of flimsy, and adding that extra dimension will add a little bit of strength to it. So, but I need to undo it because it doesn't look like it's flat. We'll float this mode. I'm actually going to save. Because saving is important. Because if you do anything in any program on any computer and have had it crash, like a normal person, I'm actually going to save over this because that one file is junk. I don't need it. If you do anything on a computer of any type of craft or whatever, and you've experienced a crash, you know that saving an application, saving whatever you were doing, can save you from many, many nightmares. And I save in iterations, and I think it's called iterations. I think that is a very good thing to do. I'm still in world mode, aren't I? Why isn't that working? Oops. Scale. Strange. I am going to freeze the transforms. And center pivot. I'll try that again. J. There we go. Okay, so if I remember correctly, the tilt is about 17 degrees, or -17 degrees, in the x-axis. So -17, maybe it's, yeah, there we go. Would have been -17. So this should line up. There we go, look at that. Now it's nice and flat, so I have a good base for printing. It will hit this part here. But because I want this to be compatible with many different types of helmets, whether you 3D printed the one I made, or you chose not to, and you bought one from somebody who makes molds of 3D printed helmets, kind of want to, you know what, it's not going to affect it that much. I'll just push this one piece back. So I'm going to move into this mode, in object mode, because I've tilted it. I'm going to pull these vertices back, and just to confirm that is staying flat, if you can see it on that far window. And then I'll pull this other one forward, so it's going to have this little notch in the front, which will make room for the mounting bracket on the front here, and maybe wires for your LED matrix on the front can go up that spot or what have you, just for proper wire management, because that's always a good thing. I'm going to break this off so that I have access to it and put it on my other screen. So now we can extrude it, because now we have a flat base to print with, and we can extrude. So extrude, attribute editor, and we'll do -4. And there we go. So there is our part that we're going to print. I'm going to readjust this guy. And from the piece that I showed you, the electronic piece that I showed you, the LEDs in this corner are gone. So there's 3 LEDs missing, so I don't have to worry about this bracket piece right here interfering with, let's get a little bigger so we can see it, interfering with the mounting of that bracket. So what we did last time is I duplicated this and then scaled it up in the X and the Z direction. Sorry, Y is up. And then I Booleaned it through, and then I cut it out. So what I'm actually going to do is I'm going to leave this one here. I'm going to scale it up, and I had an issue with cutting out this part here and manually doing it, I'm just going to scale it up even bigger so that it cuts its own groove. So we'll actually be done with this part quicker than we were before. So we'll start with saving an iteration, because I'm going to do a Boolean, and I want to come back to what I was doing. So we'll change that to 5. And anyone who's complaining watching this video saying, you can turn on iteration saving, when you hit save it'll make a new one. I don't care. Sometimes I don't want it to save an iteration and fill a folder full of files. So we'll duplicate this, and we will scale it in this direction. And I'm going to pull it. So I'm going to hide this part here so I can see it. This one and this one. Because this one has a little groove there, that's where I want it to be able to stop. It's actually just 2 resistors there. It's not a square box. This is just my template for cutting things, and I know what part I'm designing for and kind of a general idea of what it looks like. I'm going to move it up to about here so that the end lines up, and I'm going to push it a little bit beyond so that there's a little bit of wiggle room. And then because of this part ending where it does, and now it's going to be cutting here rather than over here, and I want to have room for those resistors, I'm going to move into edge mode, but on the right part, I'm going to select this edge loop that goes around the whole thing, well, almost around the whole thing. I gotta manually select it for some reason. So there we go. One more. And I'm going to slide it down so that it lines up with the other one. That way when I cut this, it'll look like the longer part, but I just have a longer end. And then I'm going to scale it in the other direction about a couple, maybe a centimeter or 2. So you see we have about a centimeter there and a centimeter over there. Just so, depending on how you put your part together, if you buy it from Alex Plus LEDs, or if you buy it from somebody else, that it's compatible with as many as I can get it to be. I only have the one, so I can't measure all of them, and I'd rather not spend the money and get a whole bunch of different things just for this one project, because I'm just going to put these up here based on what I designed for myself, and if anyone else wants to download them and print them, they're more than welcome. So now we're going to Boolean it, and we'll get our part. So I select my main part, and we select our other part. What I did last time was I checked to see if the normals were correct, and I'm pretty sure they're not going to be correct. And I am mildly right. Looks like just the outer edge has bad normals, but the other ones are fine. So to fix that, this problem with this one is we'll do normals and we say conform. And I think they are just reversed, they're just longer than normal. Yep, that was correct. So these ones that were going in the Y direction, we're actually pointing the other way down. So if I reverse them again, you can see what I was talking about. So they're as short as how thick this part was. So they were facing inside. And that can happen. It's the only way a Boolean will work is if the normals are correct. So we'll turn off our display normals. So under display, polygons, face normals. And for some reason I didn't turn that one off. Displays, polygons, face normals. Okay, this is just weird. Oh, that's right, I'm selecting the, there's 2 of them there. Now they should be off. Okay, so I'll select my base, and I select the one I want to Boolean, and it goes completely through the object and ends at the top. So there's a nice flat surface for it to be glued to with hot glue or what have you. I am going to move it up a little bit because I don't like where it's at. So select, I'm going to go to Mesh, Booleans, Difference. There we go. So I will quickly freeze these transforms on this thing so we can move it but bring it back. And that's a good trick if you're going to be doing anything with 3D printing and you're using Maya or another 3D program, is make sure that its 0 position is its final position. So that way if you end up moving it, you can just zero out all these transforms over here and it will go back to where it's supposed to be. So I can move it, grab the arrow, and if I want to move it back, I just zero everything out over here and it's back where it's supposed to be. So if you need to quickly get something out of the way, just freeze its transforms and move it. Another trick is to just quickly group it and move the group over, and then you can move the group back if you want to keep its transforms. But since this is the only one in the group, or this is the only one I'm needing to move, I won't do it. So here's our part. Kind of looks like a crab claw. So you can see we have our flat spot, which will print fine, and the flat bottom, which will fit on our printer. I'm not worried about the lack of geometry here, because it's going to be a non-visible part. It's going to be inside the helmet. It just needs to hold something, so I don't need to put a whole lot of work into making it look clean. So if I move this back, I can show you what the scaling did, and we're actually going to be done with this pretty quick. So I moved it down, except I didn't move this one up, so that's why it's cutting into the geometry. So we'll slide it up a little bit. Except now our transforms are different, so I want it to move straight up. There it is, reset transforms. So you'll see that if I look at an angle here, you can see there's a gap right there between the two pieces. There's a gap on the sides between the two pieces, the front and the back, and then there's our little groove right here that'll stop right before the resistors. There's also room in the back, so the chip is going to be, let's see here, look at the part we have here. Yeah, so the chip is right here. It doesn't go all the way to the end, but this is where the wires are. So the wires will come out the front and go down. I could push this down further and have them at the bottom, but I need the, let's see, I turn on my front chin sides. So we'll display, show all. Of course it shows everything. I'm just going to delete some of these parts because I don't need them anymore. So because these 3 LEDs are missing, I don't want to move it down any further because then you won't be able to see it. But that's how it's supposed to look on the helmet. So now we can duplicate this to the other side. There's a lot of stuff in the scene. Just hide them. You can see the fan blades that I'm printing right now. So yeah, we'll duplicate this over. Best way to do it, at least for just reference, because I only need to design one side. You don't need to design both sides if you're making something that's symmetrical. Design one side and then just mirror it. And that's just to view it, but when you're printing, you just print one, and then you print the negative in one of the axes. Preferred, I think it's the x-axis. Yeah, the x, because this is x in this direction here. So I duplicate it, I group it, that way I keep my transforms for it, and I make this a -1 for the x-axis, and now we have our part. So they'll get glued together right here. This I might adjust because it does protrude a lot. I don't think it's going to hit my chin, but it should be fine. But there we go. So in a quarter of the time, or maybe half the time. Half the time we made the same exact part and fixed it. Now we can actually do our support standoffs for this piece here. I'm going to turn off the sides and hide all these other parts. I haven't put them into a group yet to hide them with a switch yet, so I have to do it manually. That's just going to bother me. Okay, so we need to have some sort of support, because we can't just glue it on the bottom and hope that this thing doesn't rock back and forth. There's going to be, you know, might be at a rocking Daft Punk party and have to headbang a little bit, maybe, I don't know. And we want to be able to support this part so it doesn't fall out or the glue comes loose. So we're going to bring up these little supports here. And as in my last video, because this part here is at a tilt of about 17 degrees, anything that I push straight up in the Y direction globally will be tilted at 17 degrees. Now that's okay for most printers to print, but not all printers are created equal. Some can't do overhangs very well. They may not be calibrated properly. So what I'm going to do is I'm going to grab two vertices and I'm going to shrink the top so that one side will be completely parallel or perpendicular to this base plate. The other side will have a angled in. So it kind of looks like a very, very steep stairs with a wall at the other end that you can jump off, I guess. Excuse me. So we'll actually pull up these two, maybe just these two. I'll pull these two up so that you can put glue behind them and just glue it to that pillar so there's something to just support it. I won't go up too far because then it'll just take longer to print. So we'll start with these. We'll just bring them straight up. So we'll do this, and I'll just bring them up to about there. You'll see they cut into the chip. The chip doesn't go over that far, and I can just shrink them in one of the directions. So this is what it'll kind of look like. It'll just be kind of a support bracket. I'll probably put one in the front. We're okay on the front right here because it's just the terminal brackets here, or forgive me, the terminals where the wires go. The name escapes me. I'll put a little piece here just so there's a little extra support. I might put another piece on the end so there's something for this to stop against. But yeah, we're almost done. I'm going to actually undo this, and I'm going to show you how I did the fans using the technique I used for the fans for this. So we'll undo, and I think that's undone. And we will flatten this out. So we'll do mesh, or we'll proxy, and then we'll do subdiv proxy. So we end up with this weird shape. I'm going to save again, because I'm afraid that Maya might crash and make me cry. Saving is important. Yay, it didn't crash. So I have the original selected right now, so I can actually... why isn't it working? Oh, mesh, center pivot. So I can actually move this original back. So now I have two. I can select the new one, and there's settings for subdiv. I just grabbed it quick, so I don't have to go back in here and do this, but I'm just trying to show it quickly because we're live. I apologize if it's hard to hear me over the printer. I'm kind of trying to get the stuff done as quickly as possible. I'm going to set the division level to 0, and that returns me to my original piece that's over here. So now I have a piece over here that is telling this one what to do. So if I grab a pane, or a face on this, and I move it up, the one over here moves. So this allows me to flatten this one so that it's easier to work on without moving the piece that's in the right position. So I can go in here and I can rotate this and flatten it out so that I can work on it without having any issues with, oh, it's going in the wrong direction or what have you. So now I have a flat piece that I can adjust. So I'm going to be working on these two panes right here. This also lets me see the part I'm working on without having to have things in the way. So these are the two pieces I'm going to adjust. And it will mimic everything from adding vertices to edges to faces, faces, extruding. The only thing it won't do is if you Boolean anything on this, it won't copy it over here. It just creates a new object and it breaks the link. So now I have this part. I'm going to extrude these up, and thankfully they're going to extrude in a perfect perpendicular axis. I'll pull them up to about there, and you'll see that the texture disappeared. It's easily fixed. Just go into face mode. This happens to me on occasion. I think it's just the version of Maya that I'm using, and we just reapply the texture, and there we go. Texture's reapplied. Now, because when this is printed, it's printed straight up. It should be fine like that, but we're cutting into in this direction. It's tilted into it because this piece right here is technically tilted in a different direction. We have another viewer. Thank you for watching. If you enjoy the video, please subscribe. We're going to tilt this back a little bit, but instead of making the printed piece, which is right here, have an overhang on it, I'm just going to move the vertices on this side, or at least I'll grab the edges. I'm going to move them in. So it'll get thinner towards it gets to the top. And then the part we have, it's now not cutting into the part anymore. So it'll look strange, but it works. I'm going to switch into world mode so I'm editing this properly. I'll move it over and out. So there we go. So now we're not going to run into the chip here. And I'm actually going to lower both of them down so that it just lines up with the chip. This will be right about there. I'll grab the... So move this forward a little bit. Yeah, there we go. And then to save on plastic, because I don't need to have this much plastic just for this one part, I'm going to go with my top view. Or maybe I'll line this up so you can see what's going on. Do that. Okay, so my top view, I will grab these two. See how we can do this. Move them in. Basically just taper the whole top. So as it gets closer to the top, it will use less plastic, which is always a good thing. And because it's being tapered, you'll have each layer will have slightly more plastic holding each layer together. So as you get to the top, it actually makes the part stronger. Whereas if I had perpendicular walls from top to bottom, it wouldn't. The walls on the part would all be the same thickness. But since I'm tapering it in, as it goes up, it's going to add more plastic because it's. I could get into a whole video about how 3D printing works, and it probably will, but not right now. So now here's our part to hold the front on. And I think that is pretty good to go. It'll be glued in, so I don't have to worry about using screws. It's not interfering with any of the brackets. It stays within the plastic shell, which will go right on the edge here. If need be, this could be tilted back a little bit more so that the top and these other LEDs don't hit. Or you can move this whole piece in further in, I'll show you this direction, modify center pivot. You can move it in this direction, so I can get it to work. And then you pull it away, and then you just add more glue to the front, depending on how that looks for you. But there we go. There's our part. I'll duplicate it, group it, and mirror it so we can see what it looks like. So they get glued in the middle. And there's our bracket. The Thomas helmet I did, I can open it up in a second. That has kind of the same layout. There's two of them that hold the LED matrix on the front. We'll duplicate this too so we can get a good idea. Group it. There we go. And we'll turn on everything else. And I'm missing a part here. Back support, top support. Display, show, all. There we go. These are going to go into the parts folder. So are these. And so is this one. Because we don't need that one anymore. but we still make it available just in case we need to come back to that. So I'll show you the final product. Duplicate group and mirror. So this is the final helmet. Well, close to final. I still need to make the mounts for the ears, which I'll probably do in another live stream. So fan blades, and then the parts that hold these. Anyone who's new to this video may notice there's a very large gap right here, and that's because my helmet is a little bit taller than the normal ones that you would buy or make yourself, or at least the accurate ones. And I did that because my head is larger and I wanted to hide my chin. My head will fit in this right up to the edges of this. I wanted to make it as small as possible. The final one does look very large, but you know, I have a big head. But the one, when I do upload this to Thingiverse, I will modify it so it looks correct. So it looks like the normal Daft Punk helmet. And all these measurements are very accurate to what the helmet should be, except for it being stretched. And where it was stretched was right here. So you see there's a large gap between, you know, this is a small face, this is a very large face, and then it gets small again. I just dragged everything down. So it's easy to fix. I just raise it up and reposition, and it's good to go. So that's that. Anyone who's new to 3D printing and uses Maya to 3D print, or is not new to 3D printing but would like to use a 3D application, I'm going to show you how to actually export this out of here. I use a plugin. Go to Window, Display. Oh, I forget what it is. It's Window Settings, Plugin Manager. So I use a plugin. It's bottom here, and it's called multitool.bundle. You can look up multitool. They don't make it anymore, so it's a little hard to find. And it'll annoy you every time you open Maya that you're running an older version of their tool, but it is in fact the latest version. So it works great. I don't have it bug out or get all weird on me when it's exporting STL, and an STL is just it's a stereolithography file, and it's a 3D file, and it works. So when I export these, before I export them, I'll actually go into my selected view. So if I want to export this for printing, I will select it, and I go File, I go to Mesh, and I do Cleanup. And this will open up a window. It looks like this. These are my settings that I use. I just do this in case there's some weird polygon on there that's like 10 sides and doesn't have any support whatsoever, and it may cause an issue. I just triangulate everything, or at least what needs to be triangulated, before I export, so that it's as clean as possible, that when it goes on Thingiverse, there's no holes in it, people don't have any issues slicing it, which are all annoyances with 3D printing. So I click Apply, and you see the areas where I Booleaned the object are the areas that it fixes. And it put a random edge there for some reason. Who knows? So it just fixes the areas that need to be fixed. Go back into object mode. So we'll select our object, and we do File and Export Selection. And I already have stereolithography selected. There's many other types of files you can select, but stereolithography, I didn't change any of these. I left it as ASCII, and the scale is 1. If you design everything correctly scaled in here, when you bring it into your 3D printing software, whether it's Slicer or Repetier, I think it's Repetier, maybe adding an extra R. As long as you have all your scales correct, when it prints, it'll be the scale that you told it to be. So if you got a caliper out and you were measuring a part and you were remaking the part, it should reprint the way you designed it. I'm going to put it into my STL folder. That's going to go in the Guy-Man folder, and I'm going to call this, what are these called? Chin lights, I guess. Light mounts. And we'll say it's version 1.0, and we'll export. So it'll do the little ball or whatever for the Maya, but it exports really quickly. I'll jump over to Repeater, which is actually printing my fan blades, but I can show you it open because I don't need to reprint these again. So I can remove them since it's running off the G code right now. I can modify stuff in here, I just can't slice, otherwise then it'll just start printing whatever I just added for new G code. Because the printer's not smart, it's a tool, it requires input. I'll go to my Finder and go down to STL, Guy-Man, and chin mount. We'll open that up, and so there it is. So now you notice it's not flat. Why is it not flat? It's a very good question. It's also rotated. So if you design in Autodesk 123, which is free software, you can go and download it and design parts and export the STLs right from that program and print them, which is great. You just can't get, really detailed objects with it unless you use it for a really long time. So it looks like this because in Maya, let's see if I can get my center pivot. So my controls here, green is the y-axis, red is the x-axis, and blue is the z-axis. Whereas on here, z is up and down. This back, I'll rotate back to the front. X goes into, or X is left and right, Y goes into space, and Z is up and down. So because of that weird rotation inside Maya, any parts that you export, you have to line up with your Y-axis. At least the bottom has to be lined up with your Y-axis. So I don't want to move this around because I need to come back to it if I need to make changes. So what I do is I save the current one, I save a new one that the current one is saved as. So this file is called 66. Ooh, ominous. So I'll select 66, and this is just how I work. Anyone else can do whatever they want, and say print. So anything in this file has been modified for printing. That way I can go back to the original 66 and make changes, but if I just need to re-export something because it didn't quite become an STL correctly, I can export it again. So I save it as print, and now I can go and modify this file. So I will just rotate it so that it is completely perpendicular with the y-axis in Maya, like that. Turn on my grid, if that even helps. I don't even know where my grid is. Oh, there it is. So now it's perpendicular with my z-axis. So z is bottom. So now if I export this again, and it doesn't matter that the transforms are wrong or that it has a weird transform up here. Whatever you export it out as, it zeroes out everything. So we export our selection again. We'll go to our STL folder. And in the Guy-Man folder. And we'll select the same file again. And if I go back over to, so here, keep moving around on myself. So you see here, it's wrong. We have the file that we're about to save open, and this is what I like about this program. If you're on a PC, I think it does the same thing. If I re-export this, it's going to say, are you sure you want to overwrite this file? I say yes. It overwrites the file. I go back here and it says, hey, an object on your disk has changed. Would you like to reload the object? And I say yes, and bam, it's flat. I can print it, and it'll print quickly. If I printed the other one, it would add a whole bunch of support material, and it would take forever to print. Click out of position, it puts it in the middle. And this is how I design everything inside Maya or for any type of printing or product or whatever I'm making. It has to fit in my printer, because if it fits in my printer, it'll fit in anyone's printer. At least anyone who has a moderately priced printer. I think there's a MakerBot that only has like a 4 by whatever size print bed, and why? Why would you? I mean, it's $1,000 or $800 or $900 Why would you buy that thing? You can get a way better printer. Anyways, I'm rambling. So now that we have this file in here, I can hit slice. I'm not going to because it's printing right now, and you can Google anybody watching. Google anything on how to print 3D printed files. Sorry, I stutter sometimes. So here's the file. Judging by how big it is, it would probably take about an hour and a half to print. Files that are currently printing on the printer, have about an hour and a half to go, which means it'll take about 2 hours. And they're fairly tall. They don't have a whole lot of plastic to them. It's just they're complex, and they go up, and they have curved surfaces, and they have overhangs, and there's issues. So that leaves me with not a whole lot else to show. I'll probably do another video where I'll do the earpieces. I think 45 minutes is enough for a live stream. Again, please like, favorite, comment, tell me what you want me to make, tell me what I did wrong, tell me what I did right, whatever you want to do. Subscribe, follow me on Twitter, Facebook, Google+, email. Don't call me unless you want me to make you something. I take commissions, I guess. I have a 3D Hubs profile, so if you don't know anything about designing stuff, but you found something that you want printed, and you need someone to print it for you, I have a 3D Hubs profile. If you're out of state, I will ship, but I will probably have to charge for shipping. Sorry. But if you're in the area, let's see if I can grab the my actual dashboard. Here we go, my hub. So this is my hub, printed on my printer. I have red, white, clear, and red. It's $20 to start up a job, and 75 cents per unit. So if you have a file you want to print but you don't have a printer, there you go. I'll print you the helmet if you've got the money for it. It's entirely up to you. If you want to follow my updates, Twitter is probably the best place to do it. Get all my updates on the helmet and other things I'm working on, whether it be beer or this helmet itself. There's the other Thomas helmet. I did say before I would go that I would show the Thomas helmet, so I will save this because it's just the print one. I'll go back to Maya, and the Thomas one is right here, and I opened the wrong one, but it's not terribly wrong. So this includes all the electronics mounts. I will hide that part there. I designed this one from scratch. You can download it on Thingiverse. The link's in the description of the video, at least to the live stream here. It should be. Yes, it is. All the parts can be 3D printed on a 6x6 printer, and you either zip tie, glue, or screw the parts together. Kind of call it the any bed design. So here's the sidebars for the helmet. There's a bracket in here that will hold AlexPlusLEDs.com's matrix holder. So there's the holder in there for the matrix parts cut out. Basically just get some long screws and this clamps together and it holds everything very nicely. These mounting brackets will be up on Thingiverse soon. I just have to adjust them because these parts stick out too far and they kind of crush your temples. So I'll redesign them so they're curved and they don't stick out as far, because this part doesn't need to actually be that long. Thingiverse page for it is right here. Unless you glue it together, because they're zip ties. I recommend gluing it or using acetone ABS paste to do it. But that's it for today's video. Subscribe, like, comment, whatever. Thank you for watching. The 2 people watch me live. Thank you. You are awesome. And thank you to all the people who watch afterwards. So subscribe. Thanks. Goodbye. I'll leave you with the Thomas helmet while I shut down the stream.